Welcome to AP Stats Quideo number 2. This question is about this scatter plot right here, illustrating the relationship between the height of women and their fathers. I'm guessing that the person who conducted this research was trying to prove that maybe there was a relationship between the height of women and their fathers, and basically just trying to prove that relationship through a scatter plot. When we describe lines of regression, we use the base formula y hat equals a plus bx. They give you this on the actual Quideo question, which is the completed, all filled in formula. So basically our a value is 35.1, that's our y-intercept. And then our bx value, which is essentially our slope, is 0.427. So we have a y-intercept of 35.1 and a positive slope of 0.427. And you can see that line of regression detailed on the graph right here. If this graph did continue to go down here, you would see that it did have a y-intercept going all the way down here, even though there is a break in the graph. That would be 35.1 and a positive slope of 0.247, just increasing like that. And because this slope is such a small number, normally you'll see like a positive slope of like 2 or 4. You can see that they made the y-axis on this graph very, very spread out, counting by tens, and each box being a value of 2. So whoever created this graph might have made it a little bit more biased by stretching out this y-axis to make it look like it's more dramatic of an increase. Part B is basically saying that there is a father who had a height of 67 inches and a daughter's height of 61, and it asks you to circle that point on the scatter plot, which I did right here. We have that x value of 67 and that y value of 61 representing both of their heights. So yeah, that value is circled and connected with a line segment to that line of best fit, and I calculated that residual value right over here. So to calculate the residual numerically, we first need to solve for y hat because that is involved in the residual equation down here that I'll talk about in a second. But basically what I just did was I plugged in that x value of 67 where the x is in the equation. So that 67 is the father's height of 67 inches. So basically when I plug that 67 in, we get y hat equals 63.709. And then I can plug this y hat value into the residual equation, which is residual equals y minus y hat, which is essentially the observed y minus the predicted y. So that's going to be 61 minus 63 point, oh, that is a point, it's just really faint, 63.709. So y minus y hat, we get that y value of 61 from the daughter's height minus our value that we just solved for y hat, 63.709, and we get negative 2.709, which is actually an overestimate because it is below the line of regression. Part C asks us to add the data point 84, 71, so basically we have a father's height of 84 and a daughter's height of 71, and it's basically asking us how that would change the slope. Personally, I believe that the slope would stay the same because the point 84, 71 is pretty much right on the regression line. As we can see right here, it falls maybe just above it. And because it is right on that regression line, there's no way for that value to throw the slope off. Basically, it's showing that because it's pretty much right on that regression line, that this is a really good representation for the line of best fit. And there's really no feasible way for that point to throw off the slope in any way, shape, or form. The only way that I could ever really adjust the graph is like what we learned in Unit 1, how it can change the distribution and increasing the range, because now we have another data point extending all the way out to an x value of 84. But other than just changing the range, it does not change the slope. And kind of going off of Part C, Part D is asking is if this point would change the correlation at all. And I believe that this would increase the correlation because it allows you to have more proof that this is a really good line of best fit. Had the point been above or below, the point would weaken the correlation. But because it is right on there, it definitely would just increase that correlation.